So things like Anakova and Manova, I'm sorry, Manova, and those things, they seem really hard, but it's really, if you break it down, statistics is really easy if you don't have to do the formulas. If you all want me to give you the formulas and have you do the formulas and everything, more power to you. It's a whole bunch of fun. It's a ton of fun to do all them formulas. So anybody that's ever done it, if you really like it, you're special, and I love you. But for me, I'd rather just stick it in the computer and get my answers. Okay. Understanding regression analysis. Okay. Regression analysis is a statistical method for modeling the relationship between a dependent variable and an independent, or one or more independent variables. Okay. Honestly, regression is a regression model is to understand the strength and the form of these relationships and to make predictions on the dependent variable based on any kind of new data or a predictor variable. That's the bottom line. Now, you hear the word relationships. I would not give you regression now. Why? Because you have regression, you have a t-test, and you have an ANOVA, and you have correlations. You have everything. It would have been something I would have done after we did the ANOVA. We're going to go through this. I'm not going to spend a lot of time on have you understand what a t-test is and all that other stuff, because we got other weeks to do that. So otherwise, we'd be here till 9 o'clock, and y'all would really not like me. Okay. Linear regression models the relationship between two variables by fitting one linear equation to the observed data. One variable is considered to be explanatory variable. The other one is the dependent variable. Give it the idea that when you run the t-test, you're going to see the same thing, but you can't run a t-test in the same regression because it will not give you the correlation between the two. It will not give you the t value, the f value, and the ANOVA, and all these things, and the multiple levels of significance that goes into it. It's kind of like a t-test on steroids and an ANOVA on steroids, correlation on steroids, because it goes a little different. And then there's assumptions, and those assumptions are met by simply by looking at pictures. Okay, so don't make this difficult. There's funky words, funky letters, all this other stuff. If you just know the basics of it, you're going to be just fine. You're going to be able to do your write-up. You're going to have a relative understanding of it. And we're going to roll into the big one next week, which is t-tests. Here we go. All right. This came out as finance, but we could be looking at anything, and you'll see in the video, some of the data that we're going to look at, you can look at pretty much anything. One has to be a dependent, one has to be a predictor, as you've seen in your, if you already did the assignment. There's a predictor, and then there's a independent variable that just kind of roams. Okay, one setup solid, the other one can change. That's the bottom line, just like you did at your very beginning when you started doing the independent. Multiple is when you take that predictive variable and you run it against two or more, and it will look at each one separately. I always call them like round robin tournaments. It's good, like I think your homework, age and BMI and age and temperature, and then BMI to temperature. And I think that covers them all. Okay, so you pick the best one that you. I gave you the data for everything. You pick the one you want and run with it. It doesn't matter. Just do it. Okay. I think you just have to pick one. I'll double check that as we get in there. Assumptions: linearity, independence, homeosedacity, and normal distribution of residuals. Violations. These assumptions can lead to inaccurate models. Okay. So think of this way. You're looking at if these fit into a model that you can run more tests on, or you can just take the data from that test and run it. That's why a lot of people don't do a lot of multiple regression. They do a higher level of testing, but this is the basics of it. Homeosedacity is the regression refers to the condition where the variance of the residuals or error terms is constant amongst all level of the independent. This means that the spread or scatter of the residuals are uniform regardless of the value of the predictor value. Homeoscedasticity is a key assumption in linear regression. Okay, lots of big words there to tell you that when you run the regression, you're looking for the PP plot. Okay. And I'm going to show you later, the dots have to be close to the line. I mean, I don't know how to make it sound any simpler than that. And it's crazy that it's like that. You look at it, if they're all over the place on that, it's not there. You can look at other numbers, and I'm going to show you that in other numbers later, but really it's going to be that PP plot is really going to do it. You have a scatter plot, and there really shouldn't be hardly any, when you run that scatter plot on the residuals, it should be almost a flat line. And there's another type of line that you run, and you look at it. One of them comes out really good, and the other one's really good, and the other one's kind of marginal. I didn't do the data. You'd have all good. You have all good numbers. In terms of if you were to run it as a just the best fit line like we did last week, it comes out straight across. If you run the other one, it kind of goes up and down. And I'm going to show you why that happens. Okay, that's why when we talk about participants and having the right number of participants, that's a real key. Multiple. We already talked about multiple. You can do it for marketing. You can do it for this. You can do it in the hospital setting in terms of patient care to wherever. There's lots of things you can look at. In this case, we're looking at length of stay versus BMI, and that the variables have to be able to be follow the assumptions, and then you can look at just about anything. But this one gives you so much data to look at. You can get in there and start swimming around and going, well, what? Back and forth. And we're going to get to that in just a few minutes. I got one more slide. Challenges are multicollinearity, which is the regression refers to a situation where two or more independent variables in the regression model are highly correlated with each other. This correlation means that they are independent variables that share the same linear relationship. Okay. When multicollinearity is present, it becomes challenging to determine what the individual effect of the independent variable on the dependent variable, because the changes in one predictor are associated with the changes in another. Okay. The idea here is the difference between the two that we just spoke on. Okay. One looks at the individual. This one looks at the all of the variables, all 3, 4, 5, and 6 variables. Okay. It can also change the p-value, and the p-value that you're going to report, which then all of a sudden you could end up having, if somebody really looked at it, you could have a disaster where it doesn't even work at all. I'm praying that all the data comes out perfectly every week, and some weeks it won't, because I won't be able to change it that much. So you're going to report what you get. I'm going to say this now. I'm going to say it next week. I already know there's a problem with next week. I'm not stressing on it. You're going to report it as it is. You're going to run the test, and you're going to get the data, and we're going to move on. But when you do that, when you go through that process, you're going to see something that's not right. It's going to be a little bit off. It should not be that way. I don't want to give you the answer. It's not going to be, it shouldn't be that way to run the test. You report it that way. You reported it that way because you're being given something to do. And the key here is if you catch it, that's what you should be finding. Okay. I trying to beat around the bush without saying, just do it as it is, turn it in, ask the questions that you need to ask. Okay. All right. So that's the end of that one.